A massive titan of steel has risen from the shipyard as a symbol of unmatched strength and innovation. The USS John F. Kennedy, CVN-79, represents a new chapter in American naval power. More than just a warship, it sends a clear message to any potential adversary. The United States remains firmly committed to defending its interests at sea. Measuring over 1,090 feet in length and displacing nearly 100,000 tons, this next-generation aircraft carrier introduces more than 23 advanced technologies. These include modernized propulsion, expanded electrical power, streamlined weapons handling, and revolutionary aircraft launch systems. Together, these upgrades increase sortie generation by more than 30%, while significantly lowering operating costs compared to the Nimitz-class carriers. Over its lifetime, each ship is expected to save nearly $4 billion. With these capabilities, the John F. Kennedy is positioned to reshape naval warfare and give the U.S. fleet greater reach and striking power in an era of renewed global competition. As the second carrier in the Ford class, the Navy's first new carrier design in more than 40 years, CVN-79 carries a name deeply rooted in American history. It honors President John F. Kennedy, the nation's 35th president and a former Navy lieutenant who served during World War II. This is the second U.S. aircraft carrier to bear his name, following USS John F. Kennedy, CV-67, which served the fleet for more than 50 years before retiring in 2007. With CVN-79, the legacy of leadership, service, and national resolve continues. Built from the keel up as a modern command platform, the John F. Kennedy integrates systems designed to enhance combat effectiveness, reduce crew requirements, and improve survivability in contested environments. One of the most important upgrades is the advanced arresting gear, which replaces older aircraft recovery systems with a safer and more adaptable design. It can recover everything from lightweight unmanned aircraft to heavy strike fighters with greater precision and less wear on equipment. Automation plays a major role across the ship, allowing operations to be carried out with several hundred fewer sailors than on previous carriers. This not only cuts long-term costs, but also enables crews to focus more on mission execution and less on routine maintenance.
For defense, the carrier is equipped with the evolved Sea Sparrow missile, a rapid response system designed to defeat modern threats such as supersonic missiles and advanced aircraft. Its radar suite introduces the dual-band radar concept, combining multiple systems for superior tracking and engagement. Beginning with CVN-79, the powerful SPY-6 radar replaces older sensors, providing unmatched awareness across the battlespace. Aircraft launch operations are also transformed through the Electromagnetic Aircraft Launch System, or EMALS. Unlike traditional steam catapults, EMALS delivers smoother, more controlled launches that reduce stress on aircraft, increase sortie rates, and support a wider range of platforms, from unmanned drones to heavily loaded strike fighters. All of this technology is powered by the new A1B nuclear reactor, which generates far more electricity than earlier designs. This surplus power ensures the ship can support not only today's advanced systems, but also future weapons, such as directed energy platforms and next-generation sensors. Stealth improvements further enhance survivability by lowering the radar signature, making it harder for adversaries to detect and target. The John F. Kennedy can carry up to 90 aircraft, forming one of the most powerful air wings ever deployed at sea. Its complement includes FA-18 Super Hornets, EA-18G Growlers, E-2D Hawkeyes, C-2 Greyhounds, F-35C Lightning II fighters, MH-60 Seahawk helicopters, and advanced unmanned systems. Together, they provide air superiority, electronic warfare, early warning, logistics, and strike capability from a single mobile base.
One of the most noticeable design changes in the Ford class is the repositioning of the island structure farther aft. This improves flight deck efficiency and supports higher sortie generation rates. The class was designed to sustain up to 160 sorties per day for extended periods, with surge capacity reaching 270 sorties daily. While some analysts believe these numbers may be ambitious, even performance equal to the Nimitz class represents extraordinary combat power. The journey to build the John F. Kennedy reflects both industrial strength and national commitment. In 2009, Huntington Ingalls Industries received the contract to begin design and construction preparations. By 2011, the first steel was cut at Newport News shipyard, officially launching the carrier's construction. Originally planned for completion in 2018, the timeline was later adjusted to support a more sustainable 5-year build cycle.
Why replace the Nimitz class? For nearly 5 decades, the Nimitz-class carriers reigned supreme. But even legends reached their limits. By the early 2000s, these ships had reached the ceiling of their electrical output and weight capacity. They simply could not support the next wave of technology: high-energy lasers, advanced radar systems, and future electronic warfare tools. The Ford-class carriers were designed from scratch to overcome these limits. Though they resemble their predecessors from afar, internally they are entirely new. Their design rests on 3 major goals: higher sortie rates, launching more aircraft faster; reduced manpower, using automation to cut crew size and long-term costs; and future readiness, generating massive electrical reserves for technologies yet to come.
Powering the future. At the core of the USS John F. Kennedy lies one of her most transformative features: a revolutionary power system designed not for today's battlefield alone, but for the wars of decades to come. Unlike older carriers that depended heavily on steam-driven machinery, the Kennedy is engineered as a fully electric warship, powered by 2 state-of-the-art A-1B nuclear reactors. These reactors generate more than twice the electrical output of the systems used on the Nimitz-class carriers, marking a decisive break from traditional naval engineering. What makes this achievement even more striking is that the ship currently uses only about half of its available power. The remainder is not wasted; it is deliberately reserved for the future. Naval warfare is rapidly moving toward directed energy weapons, such as high-energy lasers and high-powered microwave systems, designed to counter drones, cruise missiles, and even hypersonic threats. These technologies demand immense and continuous electrical power, something older carriers simply cannot provide. For the Kennedy, however, such energy-hungry systems are not an upgrade challenge. They are part of her original design vision. This surplus power transforms the carrier from a platform limited by today's technology into one that can evolve as new weapons mature. As defensive systems shift from explosive interceptors to beams of light and electromagnetic pulses, the Kennedy will already possess the electrical backbone needed to make that transition seamless. In this sense, she is not just a warship, she is a floating power station, capable of adapting to the changing physics of combat. Nowhere is this transformation more evident than in one of her most significant upgrades, the replacement of traditional steam catapults with the Electromagnetic Aircraft Launch System, EMALS. By harnessing electrical energy instead of pressurized steam, EMALS offers smoother, more precise launches that reduce stress on aircraft and airframes. This allows the carrier to support a wider range of aircraft, from heavy strike fighters to lighter unmanned systems, while increasing launch efficiency and reducing long-term maintenance costs. Together, these innovations redefine what a modern aircraft carrier can be.
The USS John F. Kennedy is no longer just a vessel that carries aircraft. She is a power-driven combat ecosystem built to sustain the next generation of weapons, defenses, and aviation technologies. In an era where energy is as decisive as armor or firepower, her immense electrical capacity may prove to be her greatest strategic advantage of all.
A smarter way to launch aircraft. For decades, aircraft launches relied on brute force, high-pressure steam slamming jets into the air. While effective, the system placed extreme stress on aircraft and required constant maintenance. EMALS changes everything. Using magnetic propulsion, it delivers smooth, precisely controlled acceleration. This allows the carrier to launch both heavy fighter jets and lightweight unmanned drones with equal safety. The result? Less damage to aircraft, longer service life for jets, reduced maintenance for the crew. Early versions of EMALS caused problems aboard the USS Gerald R. Ford, but after thousands of test launches, the system has matured. The Kennedy now benefits from a refined, more reliable version. Faster, deadlier operations. In carrier warfare, the most important number is the sortie generation rate. How many combat-ready aircraft can launch in a single day? The Kennedy is designed to produce 30% more sorties than a Nimitz-class carrier. This leap comes from a complete redesign of the flight deck. The ship's island is smaller and positioned farther aft, opening space for rapid refueling and rearming. Instead of aircraft crossing dangerous paths, operations now resemble a high-speed pit stop, efficient, safe, and relentless. Even the weapons elevators have been reinvented. Using electromagnetic motors instead of cables, they move faster, carry heavier loads, and transport munitions directly from storage to the flight deck, cutting precious minutes from every combat cycle. Catching aircraft with precision. Landing is just as critical as launching. The Kennedy uses advanced arresting gear, a digitally controlled recovery system that replaces older hydraulic equipment. It adjusts in real time to safely stop everything from heavy fighters to fragile unmanned aircraft. As the Navy moves toward drone-heavy operations with systems like the MQ-25 Stingray and future combat drones, this flexibility is no longer optional, it's essential. The cost debate. At roughly $11.3 billion, critics argue the Kennedy is an easy target for a missile that costs a fraction of that price. Why risk so much in one ship, they ask, when smaller vessels and submarines could spread the risk? Supporters counter that cost must be measured over time. Designed for a 50-year service life, the Kennedy requires hundreds fewer sailors than older carriers, thanks to automation. Reduced manpower and lower maintenance are projected to save nearly $4 billion over her lifetime. Beyond economics lies capability. No other nation can deploy sustained air power anywhere on the globe as quickly as a Ford-class carrier. It is both a weapon of war and a tool of diplomacy. Lessons learned and smarter design. Unlike the troubled rollout of the USS Gerald R. Ford, the Navy adopted a smarter delivery strategy for the Kennedy, ensuring more systems were tested and proven before commissioning. Shipbuilders also improved efficiency using modular construction, assembling large sections on land before installing them in the hull. One major upgrade is radar. Instead of the costly dual-band system used on the Ford, the Kennedy features the Enterprise Air Surveillance Radar, EASR. Lighter, cheaper, easier to maintain, and highly effective against stealth threats. This change alone saved nearly $500 million. Conclusion. The wars of the coming decades are unlikely to offer the luxuries of secure rear bases and uncontested airspace.
Satellites may be destroyed in the opening hours of a conflict. Fixed airfields could be neutralized by precision missile strikes before aircraft ever take off. Communication networks may be disrupted, and traditional command structures challenged by cyber and electronic warfare. In such an environment, mobility becomes survival, and self-contained power projection becomes decisive. That is where carriers like the Kennedy move from being optional assets to strategic necessities. Unlike land bases, a carrier strike group cannot be easily targeted or pinned down. It can reposition in hours, operate independently, and bring its own air force, intelligence capability, and defensive shield wherever it is needed. In a future defined by anti-access and area denial strategies, the USS John F. Kennedy stands as one of the few platforms capable of sustaining operations in the most heavily defended regions of the world. More broadly, the Kennedy symbolizes a profound transformation in military technology. She represents the difficult leap from mechanical warfare to digital warfare, from the age of steam and hydraulics to the era of electromagnetic power, networked systems, and software-driven combat. This transition has not been easy. It has been costly, complex, and at times controversial. Early challenges with new systems exposed the risks of innovation on such a massive scale. Yet those struggles were the price of progress. Today, the technologies that once seemed experimental, electromagnetic catapults, integrated digital controls, advanced power management, and automated systems, are finally coming into maturity. They promise not only greater efficiency, but a level of adaptability that older platforms could never achieve. The Kennedy is not just a ship. She is a bridge between eras of warfare. In the end, her true value is not measured by how well she fights the wars of the past, but by how well she prepares the United States for the wars of the future. In a world where dominance will depend on speed, resilience, and technological superiority, the USS John F. Kennedy stands as a statement of intent that American sea power is evolving, not retreating, and that the future of deterrence will be carried not on yesterday's steel, but on tomorrow's innovation.
Enjoyed this deep dive? Tap subscribe and keep the latest defense tech coming straight to you. Thanks for watching. See you in the next video.